Good day everyone, I am Jeffro Quinto Sagario and I am your future mathematics teacher. In today's video, we are going to talk about the frequency distribution. So what is frequency distribution? So a frequency distribution, it is a tabulation or grouping data into appropriate categories showing the number of observation of each group or category. So what is the importance of frequency table? So the importance of it is used to analyze data, used to estimate the frequencies of the population on the basis sample, and third, used to facilitate the computation of various statistical measures. Okay, parts of frequency distribution. First is the class limits. It is groupings or categories defined by the lower and upper limits. Second, the class size. It is the width of each class interval. Third, class boundaries are the number used to separate without gaps created by class limits. And lastly, the class mark are the midpoint of the lower and upper class limits. Steps in constructing a frequency table. So this is the example of our raw data. In determining the range of our raw data, is first we need to find the highest score and the lowest score. Since our highest score is 9 and our lowest score is 2, we need to subtract 9 and 2 to get our range, which is 7. Second step is we need to determine the number of class interval. So we need to follow this equation. C is equal to the range over the desired number of class interval. Since our range is 7 and our desired number of class interval is 3, we need to divide it 7 and 3, which is the answer is 2.33, round up to the nearest whole number, which is 3. The third step is to set up our class limits. In setting up our class limits of each class is we need to follow this equation. Lower limits of the class interval is equal to the class limits multiplied by the number of class interval minus the perfect score. So, since our number of class interval is 3 and our class limits is also 3, we need to multiply it. 3 times 3 is equal to 9 minus the perfect score, which is 10. So 9 minus 10 is equal to 1. So our lower limit is 1 and our upper limit is 9. So the fourth step is tally the scores and add it for the frequency. So in tallying, we need to find the scores which belong to each class interval. So according to our raw data, there are 5 students whose scores belong to our first class interval, and there are 8 students whose scores belong to our second class interval, and there are 12 students whose scores belong to our third class of interval. So the fourth step is tally the scores and add it for the frequency. So in tallying, we need to find the scores which belong to each class interval. So according to our raw data, there are 5 students whose scores belong to our first class interval, and there are 8 students whose scores belong to our second class interval, and there are 12 students whose scores belong to our third class of interval. So let's proceed to our fifth step, to set up a class boundary. In setting up our class boundaries is we need to follow this equation. B is equal to the lower limits of the second interval minus the upper limits of the first interval divided by it 2. Since our lower limits of our second interval is 4 and our upper limits of the first interval is 3, we need to subtract 4 and 3 to get 1 divided by it 2 to get 0.5, our class boundaries. To set up our class boundaries, we simply need to subtract 0.5 to all our lower limits of our class interval and add 0.5 to all the upper limits of our class interval. Our last step is to solve the class mark or midpoint. In solving our class mark is we need to add from our score interval, the first score interval, which is 1 plus 3 is equal to 4 divided by 2, which is equal to 2. And then 4 plus 6 is equal to 10 divided by 2, which is equal to 5. Next, 7 plus 9 is equal to 16 divided by 2, which is equal to 8. So our class mark is 2, 5, and 8. Let's proceed to our next topic, the cumulative frequency distribution table. The less than cumulative frequency distribution is obtained by adding frequencies successively from the lowest to the highest interval, while more than cumulative frequency distribution is obtained by adding frequencies from the highest class interval to the lower class interval. In solving the less than cumulative frequency is we just need to copy the preceding frequency, which is 5. So 5 plus 8 is equal to 13. 13 plus 12 is equal to 25. Next, in solving the more than cumulative frequency is we need to start from the bottom and copy the preceding frequency, which is 12. So 12 plus 8 is equal to 20, and then 20 plus 5 is equal to 25. As you can see, we have the same answer for our less than and more than cumulative frequency distribution. Makes sense because 25 is our total population. Let's move on to our next topic, which is the relative frequency distribution. The relative frequency distribution of class is the frequency divided by the total frequency or total number of observation, and is generally expressed as a percentage. To solve our relative frequency distribution is we need to follow this equation. Relative frequency is equal to the frequency of each class interval over total number of population. So 5 divided by 25 is equal to 0.20, and then 8 divided by 25 is equal to 0.32, and then 12 divided by 25 is equal to 0.48. So to get the relative frequency percentage is we just need to multiply it by 100. So 0.20 times 100 is equal to 20. 0.32 multiplied to 100 is equal to 32, and then 0.48 multiplied by 100 is equal to 48. To solve for our less than and more than relative frequency distribution, the same process will be applied. So we just copy the preceding number, which is 20. 20 plus 32 is equal to 52, and then 52 plus 48 is equal to 100. The same process, we start at the bottom. We need to copy the preceding number, which is 48. So 48 plus 32 is equal to 80, and then 80 plus 20 is equal to 100%. It makes sense because overall the total will be 100%. Let's proceed to our last topic, the graphical representation of the frequency distribution, a histogram. A histogram consists of a set of rectangles having bases on a horizontal axis, which centers on a class mark. The base width corresponds the class size, and the height of the rectangle correspond the class frequencies. So this is the example of histogram graph. Next, the frequency polygon are constructed by plotting class frequencies against class mark and connecting the consecutive points by straight line. So this is the example of our frequency polygon. To further illustrate our lesson for today, let us have another example. Let us refer to our raw data that is being flashed on our screen. Following the steps, we will first determine the range. Now, since our highest score is 47 and our lowest score is 22, so we need to subtract it together to get our range. So 47 minus 22 is equal to 25. Our next step will be determining our class interval. So since our perfect score is 50, so our class interval will be 7. The next step is to determine our class size. So here is our formula. So to determine our class size is we need to find the C is equal to 25 over 7. So 25 over 7 is equal to 3.57. Round up to the nearest whole number, so 4. The next step is to set up our class limits. So we need to follow this formula. Lower limit is equal to the perfect score minus our class interval times our class size. So since our perfect score is equal to 50 minus our class interval is 7 and our class size is 4, so 7 multiplied into 4 is equal to 28.
Minus
28. So 50 minus 28 is equal to 22. So we will put 22 here as our lower limits, and then we need to count 4 units to get our upper limits. So we need to start from 22, 23, 24, and 25. So our upper limits is 25. Since 25 is already here, so we need to start at the next number, which is 26. So 26, the same process, we need to count 4 units to get the upper limits. So 26, 27, 28, and 29. So our upper limits is 29. The same process as we go on until the end. In tallying, we need to count the score, which belong to our score interval. So we need to refer from our raw data. According to our raw data, the tally of our first interval is 3. The tally of our second interval is 5. Next, the tally of our next interval is also 5. And the tally of our next interval is 7. The tally of our next interval is 10. The tally of our next interval is 7. And lastly, the tally of our last interval is 3. Finding the frequency is we just simply count the tally. So first is 3, second is 5, next is also 5, next is 1 is 7, next one is 10, next one is 7, and the last one is 3. So this is our frequency. In finding the class boundaries is we need to use this formula. So V is equal to 25 minus 26. So 25 minus 26 is equal to 1. And then 1 divided by into 2 is equal to 0.5. So to use this 0.5 is we just simply subtract 0.5 to our first interval and then add 0.5 to our second interval. By getting our class mark, we will simply add our lower limits and the upper limits from our score interval. So 22 plus 25 is equal to 47 divided by into 2 is equal to 23.5. Same process. 26 plus 29 is equal to 55 divided by into 2, it is equal to 27.5. Process 31.5. equal to 35.5, 39.5, 43.5, 47.5. So this is our last mark. So let's proceed to our next part, the less than and more than cumulative frequency. So let's solve first the less than cumulative frequency. So by solving this is we just need to copy the preceding frequency, which is 3, and add to the successive frequency, which is 5. So 3 plus 5 is equal to 8. And then the same process, add to the successive frequency. 8 plus 5 is equal to 13. And then 13 plus 7 is equal to 20. 20 plus 10 is equal to 30. And 30 plus 7 is equal to 37. And then 37 plus 3 is equal to 40. The next part is the more than cumulative frequency. By solving this is we need to start at the bottom. The same process, we need to copy the preceding frequency. So since the preceding frequency is 3, so we just need to copy the 3, and then the same process, copy to the successive frequency, which is 7. So 3 plus 7 is equal to 10. 10 plus 10 is equal to 20. 20 plus 7 is equal to 27. 27 plus 5 is equal to 32. 32 plus 5 is equal to 37. And then 37 plus 3 is equal to 40. Which is our more than and less than cumulative frequency is correct because we find our population, which is 40. By solving our relative frequency is we just simply need to follow this formula. So frequency over population, since our frequency is 3 and our population is 40, is we just need to divide it. 3 divided by 40 is equal to 0.075. And then next, the same process, 5 divided by 40 is equal to 0.125. Since this is 5, we just need to copy 0.125, 0.175 to 0.25, 0.175, 0.075. So, in solving the relative frequency percentage is we just simply move two decimal places from our relative frequency. So, just move two decimal places, 1, 2, put the point there. So, our relative frequency percentage is 7.5. Next, 1, 2, so 12.5. The next, also 12.5. Next, move the two decimal places is equal to 17.5. And then two decimal places, so 25. And then so two decimal places is 17.5. And then lastly, go to two decimal places, which is 7.5. So this is our relative frequency percentage. Lastly, we need to find the less than and more than relative frequency percentage. So the same process, you need to copy the preceding number and add it to the successive number. So since the preceding number here is 7.5, and then add to the preceding number is 12.5. So 7.5 plus 12.5 is equal to 20. So 20, since this is more than relative frequency, is we need to do the same process.
we need to copy the preceding number, which is 7.5. So we need to write 7.5 here and add it on the successive number, which is 17.5. So 7.5 plus 17.5 is equal to 25. And then 25 plus 25 is equal to 50. And then 50 plus 17.5 is equal to 67.5. And then 67.5 plus 12.5 is equal to 80. 80 plus 12.5 is equals to 92.5, and then 92.5 plus 7.5 is equal to 100. So which is correct since we met the 100% of our data. I hope and I pray that you have learned something from this video, and thank you for patiently listening, and see you next time. I hope